Hello, my name is Dr. John Littlewood from the Sustainable and Resilient Built Environment Group at Cardiff School of Art and Design in Cardiff Metropolitan University in South Wales, UK. Today I'm going to speak to you about measuring occupant quality of life in dwelling retrofit as part of building performance evaluation projects. So to give some context to this, in Wales we have a piece of legislation that was introduced in 2015 called the WellBeing of Future Generations Act, and where projects in Wales that have some form of government funding, those projects, whether in the public or private sector, are encouraged to demonstrate how they'll meet the 7 pillars of the Wellbeing and Future Generations Act. And in particular today, I'm talking to you about a healthier Wales, how we make a society in which people's physical and mental well-being to be maximised, and which choices and behaviours that benefit future health are understood. So I'm going to present 3 short case studies related to dwelling retrofit and how we're looking at a healthier Wales. So our quality of life, we use the definition from Kesey et al., Quality of Life in Europe from 2015, which has got 8 parameters: natural and living environment, governance and basic rights, economic and physical safety, social relations and leisure, material living conditions, productivity or main activity, health and education. And today I'm going to show you examples of 5 of these parameters related to dwelling retrofit projects. The first context is to a PhD project that was funded through something called Knowledge Economy Skills Scholarships, the first part of the programme, which was structural funds, EU structural funds, and also it was funded by Coastal Housing Group, a housing association in Swansea. And we looked at the impact of exterior wall insulation on existing dwellings that were built prior to 1919, and these were being retrofitted as part of a programme called ARBIT. ARBIT stands for Save in Wales, and there have been 3 strands to this programme. It's still ongoing, and it's upgrading existing dwellings both in the private and public sector where households are in fuel poverty. Fuel poverty is defined as where occupants are spending 10% of their household income on operational energy use for space heating. And therefore the houses were already identified by Coastal Housing Group to achieve the funding, and we were looking at the impacts of exterior wall insulation on reducing and eradicating fuel poverty for occupants where exterior wall insulation was retrofitted. Now, we used a number of methods to assess this: thermography, site observations before and after retrofit, analysis of construction detailing and specifications. The top left image shows the typical type of housing we were engaging with. Terraced housing built prior to 1919 as part of the Industrial Revolution in Wales. And in this case in Swansea, built as the Docklands in Swansea rapidly expanded in the 18th and 19th centuries as a result of iron ore production and also coal production. So the docks were used to export the products from Wales to the international market. So the houses were built not to last more than 20-30 years for the workers, but they're still standing in 2021. The methods we used identified a number of unintended consequences whereby occupants weren't taken out of fuel poverty because the retrofit measures weren't always satisfactory. So for example, the middle image here shows the detail drawing shows how the window reveals weren't retrofitted, and therefore that created an unintended thermal bridge, which led to, in some cases, because of inadequate ventilation, mold growth on the internal surfaces of the walls, which had then a detrimental impact on occupant well-being and indeed quality of life. We can see also at the bottom left, with some of our site observations where the retrofitted wall insulation was installed, it wasn't always installed correctly. We can see that it's actually shaped in an unusual form here, around actually the scaffolding poles that the workers stood on to apply the insulation. However, we have got two examples through the thermograms that show an improvement to the heat loss from the fabric from left to right. The left image is before retrofit and the right image is after retrofit. So the consequence of ARBIT 1, we found that whilst there was a decrease in a number of the case studies in terms of energy usage, unfortunately there was a rise in energy costs. Why was that? It's because the wholesale energy market increased during the project, and therefore there were lessons to be learnt. But the findings of the work led to governance and basic rights policy improvements, which led to amendments to ARBIT 2 and beyond. And indeed, Joe Atkinson, who undertook the PhD, went on to work for the Carbon Trust and worked on some other retrofit projects and took the learning from this PhD into those retrofit projects. And some of our findings were published in Energy Procedure and in Engineering Sustainability. And this project was finished in 2015. So building on this, we went on to work on ARBIT 2. So in this project, it was managed by two external stakeholders. Melling Homes, they managed the retrofit program in South Wales, and a contractor managed the retrofit program in North Wales. Now, based on our findings from ARBIT 1, where we determined that there were a number of impacts on quality of life, health and well-being through those unintended consequences, our focus here was to investigate the impact of dwelling retrofit on occupant quality of life using a questionnaire called Short Form 36, which is a questionnaire that was developed many years ago to investigate 8 parameters of health, from individual feelings, emotional health, daily activity, happiness, work, energy, physical health and social aspects. So as part of the quality of life criteria that we use, this touches upon health, governance and basic rights, natural and living environment and material living conditions. This was a second PhD project which started in 2017, and the candidate is currently writing up his thesis down here in the bottom left. Indeed, he was presenting at the SEEDS 2017 conference at the start of his project, Denis Jechik. And this project has also led to some policy documentation, which we have published through a number of academic peer-reviewed publications. And indeed, what we found through ARBIT 2, which was an improvement on ARBIT 1, across the 8 parameters after retrofit, there was an improvement for physical functioning, role limitation due to physical health, role limitations due to emotional problems, energy fatigue, emotional well-being, social functioning and general health. Pain and role limitations due to emotional problems, there weren't any changes. So this was good to see that the ARBIT 2 program had led to improvement in health. Now, when we started the study, the ARBIT 2 program was almost at the end. So our surveys, whilst we've got before retrofit measures, we actually undertook the survey before and after retrofit surveys after the work had been completed. So building on those findings, we're working on another project now called Optimise Retrofit, which is Pan Wales, which we're going to come on to a moment. And indeed, some of the findings from this PhD project have led to a number of other publications developing management guidance for government funding dwelling retrofit schemes to improve occupant quality of life, and piloting a management and evaluation protocol for occupant quality of life in Welsh dwelling retrofit projects. So the next element of the work, which is related to health, is not engaging in surveys, but it's actually something we've phrased as the safety gap. and we measure the safety gap by investigating physical safety as a result of air leakage in properties. So we've developed a qualitative and quantitative test method where we can determine whether compartmentation and fire stopping is adequate or inadequate in existing dwellings, or existing dwellings using a combination of blower door tests, smoke testing, and indeed quantitative and qualitative measurement of smoke spread. So for qualitative measurement, we're using static and mobile video cameras positioned around the dwellings, and for quantitative measurements, we're using static and mobile particulate matter sensors. Which leads me on to the Optimised Retrofit project, where we're taking the learning from those 3 projects for occupant engagement and fabric assessment, and we're able to map into government and basic rights, economic and physical safety, natural living and living environment, material living conditions, and health. And we're one of 68 partners in the Optimised Retrofit project, which is led by Zero Homes and Pobble Housing Association. It's funded by the Welsh Government, and we're looking at retrofitting over 1,700 existing social housing dwellings in Wales to near to net zero carbon. And the projects we're managing are you comfortable? So we're looking at occupant comfort and quality of life. So we're using a short form 36 questionnaire to engage with approximately 200 households across 13 housing associations in Wales, and we're using our safety gap measurement approach to measure the impact of air leakage on physical health for thermal comfort, mental well-being through sound pollution, and also physical health and safety if there's any air leakage that could lead to smoke spread, toxic gas spread, or fire spread in the event of a building fire. And that's the end of my presentation. If references are available on request, and any questions can be taken at the end. Thank you very much.